All right, folks, let's get started. Office hours, Thursday, July 13th. I'm going to share my screen. And go through the agenda in the Google Doc. Copy link URL. Just gonna paste this in chat in case anybody doesn't have it. Feel free to add things there or to just pop them in the chat for Zoom, which I will also try and open. Oh, it is open. There we go. Awesome. All right, so let's get started. Someone asks, some anonymous user asks, what is a good example of caching? Does the person who added that to the agenda want to out themselves and expound upon that? That's optional. I can just guess what you meant. But if you're here and would like to add more context, now's the time. No, okay. Good example of caching. So caching is kind of a more general concept that you'll find a lot in programming languages and programming applications, especially in the web. You see a lot of this. Caching happens sort of all over computer science, and the basic idea is you have something that's expensive to get, some piece of data that's expensive to get. So this could be data that's expensive to get because you have to compute it and it takes a long time to compute that data. Or it could be expensive to get because the place where it's stored takes a long time to get the data from. So it could be that the data is stored on a server on the other side of the world, and it takes a long time to for that request to happen. Or could be data that's stored on your hard drive, which is a lot slower to get data off of than, say, data that's in memory. So caching is sort of always this procedure of fetching something that's expensive, either from somewhere that's far away or hard to get to, or generating data that's hard to compute. And then once you have it, storing it somewhere where you can access it quickly. And none of that has given you what you're asking for, which is a good example. So let's look at a good example of caching. And to do that, I will just write some JavaScript. So let's think of what's a good example of something like this. So let's say that okay, so let's say we have a function called compute.
Excuse me, Trevor. Are you recording this?
I am recording, yes. Yeah, I turned it on. Thank you for asking. So we are recording. So let's say we want to do something that is going to take a long time, some sort of difficult computation. Or let's say what we want to do is we're gonna run some expensive query in the database. That might be a really good example, right? So we have some, find average age of Facebook user, right? So you have some thing we want to do that's takes a long time. Finding the average age of Facebook users, right? So we would have to go and add up the ages of every user on Facebook and then divide by the number of users on Facebook. That's a lot of numbers to add up and divide, so we can see that that would take a little bit of time, right? If we wanted to post that on the homepage of Facebook, for example, Facebook wanted to have an ad on their homepage that said, our average user is 68 years old, or whatever the average is, probably not 68. Then they wouldn't want to have to do that work every time someone hit the homepage of Facebook, right? Because that's happening millions or billions of times a day. So you'd want to have some faster way to do this, right? So let's say this is the find average age of Facebook user. method, and we're just gonna to simulate something that's gonna take a long time. We're gonna make this an asynchronous method, right? Give it a callback, and we're gonna say set interval. We'll call this 3. Well, I'm going to say it takes a second, so I'm going to set an interval of 1, and then what we're going to do is, oh, sorry, my editor is having a little tantrum. Okay, so to simulate this taking a long time, we're going to do this set interval thing here. And then in the interval, we'll call callback with the result, right? And we'll say the average age is 26, right? So if we run this thing, find average age Facebook user, and then for our callback, we're going to just create another little function here that gets the age and prints it out. That looks reasonable. All right, so what happens if we run this code? Node, execute this file. Takes a second, and then it does. Callback argument must be a function. Did I do set interval backwards? Oh, also, I don't want set interval, I want set timeout.
Oh, you have a typo.
Yeah, timeout. Thank you. Okay, so waits a second, prints out 26, right? So this is your case of like, I have this function, but it's slow, right? This thing that I'm doing on lines 4 through 6 takes a long time. So an example of caching would be to do something like this and say, okay, I'm going to set a cached response. I'm going to create this variable here and just leave it unset. And then I'm going to say something like, if, actually we want to do this out here. So I'm going to put this, declare this variable here outside of the function, right? And I'm going to say, if I have a cached response, return cached response. Otherwise, we're going to do this set timeout, right? And what we'll do instead of calling the callback with the value 26 is once we figured out that the value is 26. So right here, there's like some code like go compute this thing, right? So this is the code that we're just sort of omitting, right? That like takes a long time, right? Somehow we get the 26 back to pass to the callback. But what we're going to do is we're going to pass it to the callback, but then we're also going to save it. We're going to say cache response equals 26. So we're basically saying, hey, remember next time someone asks, the number is 26. And we're not going to return the cache response. We're going to call the callback with the cache response. Here. Asynchronous code is hard. Okay, so now what's going to happen is if we call this thing several times, and let's do this, log start, and let's change this to 3 seconds just so that we can see it, right? So we have this thing that should take 3 seconds. First time we come in here, cache response is not going to be defined. So this if will fail. So we'll skip on down to here and we'll run this set timeout. And then 3 seconds later, we'll execute the callback with the return value and we'll put it in the cache response. Probably a better way to say this would be. All right, so we stick it in both places. Then the next time the function gets called, cached response is defined now. And so we always just hit this block and we short circuit it. So let's run that and see what that looks like. So it starts, 3 seconds go by, and then all of a sudden we get everything printed out at once, right? So the first time it took us 3 seconds to print the 26, and the next 3 times it finished instantly. So that's a good example of caching, right? You've got something that takes a long time. So the first time you execute that computation or you go fetch that data, you save it somewhere in a cache that's fast. In this case, we're just using a variable in memory as a cache, which is a really common thing to do. And this sort of idiom of having a function that the first time you call it does something expensive, and then every other time you call it, it just remembers what its return value is supposed to be, is called memoization. Memoization. So that's sort of a common pattern in programming languages, is memoizing a function. They're actually, we'll leave this as an exercise to the reader, but you can actually write a function that wraps any other function and memoizes it automatically, right? So that might be a fun thing for y'all to work on if you're interested. But there, you can sort of, this is a common enough idiom that you can just sort of automate it, and you could write functions that sort of take in a normal function and then return a new function that's sort of the old function but memoized, so that subsequent calls are fast. Can you please repeat what memoization means? Yeah, memoization is just what we did here. It's a function basically memorizing its own return value. So the first time it computes its return value, like here, it remembers it, and then on subsequent calls to that function, it just returns the remembered value. I don't know why they call it memoization and not memorization or caching, but that's what they call it. Other good examples of caching are going to be what your web browser does. So in that case, right, your web browser, you load yahoo.com, right? And there's about 78,000 assets that this page has to load, right? It has to load the HTML, but then it has to load every single one of these images separately. And all the CSS and HTML and the CSS that gets loaded on this page, right, is probably the same CSS file that gets loaded when I go to the finance page. So for my browser to have to download that same CSS file over and over and over every time I click on a page in Yahoo, it just takes a lot of time. And so the browser will cache that page. It'll save that CSS file on my hard disk somewhere, or possibly even in memory. So that as I'm clicking around the Yahoo site, it knows, oh, this page says it links to this CSS file, but I already downloaded that for the last page, so I'll just use my downloaded copy. It's another example of caching, which is that whole thing when you go and have to clear your temporary internet files. That's what you're doing. You're clearing out the cache that your browser has stored. That's what those temporary internet files are.
Hey, Trevor, does it cache every time you go to the website? Like, does it refresh the cache? Because wouldn't you run into the same issue as something becoming dated?
Yes, you would. So it turns out that there's this whole protocol of headers, like HTTP headers, that specify how long a file can be cached or should be cached. So, for instance, like if I go to Gmail, right? I wouldn't want my browser caching my Gmail page, because I actually want to see if I have new emails. I don't care what it looked like yesterday, right? I always want that to be up to the second, so it should never cache that. But things like the Gmail logo that gets loaded in that page is probably not going to change, yearly. And so what a web application will do is it will send back different headers for different types of assets to tell browsers, hey, this thing is safe to cache for an hour, versus this other thing, you should never cache it. There are other strategies for dealing with that. One is, so you know how in Git you have those long strings that represent a git commit. These things here, right?
Yeah.
Where it's sort of like it's a hash based on the content of everything that's in your repository and that commit, right? Mm-hmm. So it's sort of guaranteed to be unique for that combination of files. So you can actually compute this for a CSS file, for instance, or an image, and then use that as the image name, or use something unique like that in the image name, and then just tell the browser, hey, you can cache this thing forever. Mm-hmm. And then, because if I ever update that image, I'll just I'll rename it to whatever the new hash of its contents is, and so all the links to it will change. So there's several different strategies for sort of invalidating cache. It's often said that the two hardest problems in computer science are naming, cache invalidation, and off by one errors. Cache validation makes that list for a good reason. It's a complicated problem, and it's easy to get wrong, and you do end up with a lot of things like, oh, this thing is cached, and it's a hard problem, but it's something you kind of necessarily have to do to work around the fact that the internet is slow at times, or the speed of light is a limiting factor.
Okay, cool. Thanks.
Yeah. So number 2, did anybody else have any questions? Other questions on caching? Did I cover what was wondered? Okay. If anything else comes up, feel free to add it to the agenda. Can you test promises in Mocha and Chai? Yes, you can. Let's look at an example of that. So I started poking at this for a few minutes before we started, so I've got something going. So let's say we've got, so here's a function that returns a promise. I'm going to assume for the purposes of this explanation that if you're asking about testing promises, you have some exposure to promises, right? So this function just returns a new promise that adds 2 numbers. So it's an asynchronous method for adding 2 numbers. It's like the built-in addition, only worse because it's asynchronous, right? And so we've got 2 cases, right? If you passed in 2 numbers, then I will just call the resolve function with A and B. Otherwise, I'll reject the promise. So it's a simple function that returns a promise. It should add 2 numbers or throw an error. If what it's being asked to add is not numbers, are not numbers. So let's look at a test for that. Let's get rid of that for now. So here's the first way we could test this. This is just using Mocha and Chai, like we're used to. And it turns out that Mocha, normally it has that done method here, right? That you have to call to tell it like, hey, all my asynchronous things are finished in this test. Mocha will also allow you to just return a promise from your test. So if I have a function that I'm testing that I know returns a promise, then I can just say, I can call that method and I can use .then to sort of, add sort of an asynchronous callback, right, for the promise. So I can say, okay, then when the promise is resolved, take that result and then run my expectation. I expect that the result should equal 5 because 2 plus 3 is 5. And I'm pretty sure that works. Yay, that works. Adds 2 numbers. So the test passes. So it's very similar to testing a method that takes a callback. So if add async took a callback, we would just change this to this, right? This callback would just be the third function. And then the difference is we'd have to do this done thing, right? Done. So this is what it looks like when you're like testing a method that has a callback, right? You just put the tests in the callback and call done. When you're testing promises, just put the tests in the then, and then return that whole promise. You could do the done thing here, but it's a little redundant if you have already got a promise going on. So like that would be another option. But I would say If you can, just return a promise. Just return a promise. It's simpler. Does that answer the question? Is that clear, or do I need to explain that better? Make sense to everybody? Mm-hmm. All right. Cool. So what are some good practices on writing asynchronous tests? That's a broad question. What are some good practice on writing asynchronous tests? It's a good question. Nothing is like jumping to mind as like, oh, specifically with asynchronous tests. There are some gotchas with writing asynchronous tests. So let me see if I can go back to this thing. So say we've got this asynchronous test here. There are a few gotchas with something like this. One is this done method, right? Like you just need to make sure you're always calling done or your tests will hang. And it's possible, it's possible to end up in situations when you're passing callbacks around and then you're putting your tests like inside a callback. You want to make sure that that callback is actually getting called. And this done thing sort of takes care of that for you. That's partly why it's there, to sort of make sure that like the callback's getting called. But I would say just as a good practice for writing tests in general, you always want to see your tests fail. You want to prove to yourself that your tests will fail if the code behaves incorrectly or behaves different from what the test asserts. Which is one good reason for like test-driven development is you can, if you write the test first, then you know it's always going to be failing when you first write it. So you're sort of proving immediately that the test can fail and fails under the right conditions, and then you write the code to pass it. If you've already have the working code and you're just writing tests that pass as soon as you write them, you probably want to come in and like change the conditions of the test to just force it to fail, to show that like it will fail for the right reasons. And I bring that up within the context of asynchronous tests just because when things are happening asynchronously, it's possible you get in situations where your test is passing because your expectations were never run at all, right? And you just want to make sure you avoid that pitfall. Unfortunately, not a lot of other stuff is jumping to my mind as far as good practices specifically for asynchronous tests. Yeah. I mean, the funny thing about JavaScript is that like it's all asynchronous. So you'll notice that like this it is an asynchronous method, right? You pass it a name of a test and then a function that's going to get run at some asynchronous point in the future. So it's kind of, it's all asynchronous all the way down. Even when you don't think you're writing asynchronous tests, you kind of are. Helen's asking, how would you test multiple thens? Let me go back to this. So multiple thens, I'm not sure. Can you expand on that a little bit? Like what situation are you envisioning there where we'd have multiple thens? Helen, you still there? I'm just curious if you can. Yeah, so there's not really, so the way then works, right? If you chain these together, at this point, this second then is sort of, it's going to get past the return value of the previous then, which in this case is just going to be undefined because we're not returning anything from this then. So if you start chaining thens together in your tests, you're not really testing the initial method anymore. Now your then is sort of tied to this like expectation callback. So I don't know that it makes like there's a good reason that you would need to chain thens together in a test like that, if that makes sense. if you need to do multiple expectations, you just put them all in the same then block. So the next question is about the difference between unit tests and integration tests. So unit tests and integration tests. The idea behind a unit test is you're testing one piece of your code. You're taking some sort of block and isolating it and saying, okay, I'm gonna, it's usually like a function, right? I'm gonna test this function sort of in isolation. I pass in something, I expect this other thing to come out the other end. And so unit tests are useful for testing like your application at like a smaller granularity, where you're testing individual pieces of your application. Integration tests are tests where you're sort of testing the application as a whole. So I'm trying to think of a good analogy for this. So I'm trying to come up with a car analogy, and I don't know enough about cars, so it was a bad thing for me to reach for. What's a good analogy for this? So okay, so how about this for an analogy? If your application was like a basketball team, right? So you've got lots of people on the basketball team, and they all work together to like play basketball and win a basketball game. You can test each individual player, right? By like testing them on dribbling and shooting and those types of things, right? And you could sort of assess all of your players and keep an eye on them and say, okay, I know that every player on my team can dribble, pass, and shoot, right? And that's sort of like your unit tests, right? You're testing individual pieces of your application to make sure they're behaving as expected. They're able to do their job the way they are supposed to do their job. An integration test is sort of testing that the basketball team can win a basketball game, can actually play basketball together. Because when you've tested all the individual pieces, what you still haven't quite tested is the pieces working together. It's sort of that glue that holds the application together, and integration tests sort of help you test that whole thing. Let's see. Here's a good example. Well, let's not promise that it's a good example, but here's an example, right? So say that I have a function that is going to uppercase a string, right? So it's going to take some string and it's going to convert it to uppercase. And I'm going to have to Google that because I forget. Uppercase. No, it's like two upper or two uppercase, two uppercase. String to uppercase. So to uppercase, nothing too scary there. And I might have another string that's gonna, another function that's gonna reverse the string. And another function that's gonna trim the string, right? So we're gonna string, what is it? Endian. Here's a substring. I thought so. So we're gonna trim the string, and we're gonna get the first 10 characters or so, right? Okay, so we got these three methods, and we could write tests for these methods, right? We could say, let's describe upcase and say uppercase is a string, right? That's easy to write. Expect uppercase AA to equal AA. That window is way too small. And then let's add tests for the other things. This one can reverse a string. Reverse AB should be BA. And
reverse is spelled incorrectly on line 9.
Rever. Is that right? Does that look better?
Yeah.
Reverse. Yay, thank you. Okay, reverse. And then what was the last one we had? Trim. Trim is a string. Reverse is a string. Trim. And then we'll have some string here, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 1, 1, 1, 1, 1, 1. Right, and that should get trimmed down to 10 characters, so it just should be this part, right? Okay, so let's make sure those work. Fiery, fiery death. Unexpected token, comma, the Dickens you say. Syntax error. Boom, 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 boom. I don't know, that looks right to me. What am I missing, folks? We got functions, we got describes, we got functions up here. We got all kinds of functions. We don't need this anymore.
Should upcase have another parentheses?
Yes, I think you're right. Here it is. Yep. And I copied that bug into all these other ones. Thank you.
You're welcome.
All right. Okay, so unit tests, right? All of my functions work right, except reverse, because I can't spell. Reverse, string reverse. Isn't that a thing? Is it not a thing?
I actually don't think that's a
That's not a thing. Okay,
Not
so this
exactly.
has to, oh, yay. So now we need, okay, so we're gonna split the string and then reverse the array and then join the string back together. Let's see if that works. Expected AB to equal BA. Okay, time to just try that by hand. AB split. Ah, there we go. That's my problem. I have to actually split it on empty string to get each character. Yeah, join defaults to comma. That's not what we want. Okay, so now I've got these unit tests, right? All of my code works. But these little functions are probably going to end up being used in some like larger function, right? So let's say we had a scramble function. And you can sort of imagine that these little functions are all the different modules in your big web application, right? And scramble is like your routes, right? Like the application as a whole, right? That takes in some like request from a user and then returns some HTML page. So this is like our overall thing. And Scramble actually uses all of these functions, right? And let's say that what we're going to do to scramble a string is we're going to trim it, and then we're going to reverse it. Well, actually, so let's start with the test. This will be more interesting. So let's make these unit tests. And
I can't hear you anymore.
oh no. How about now? Can you hear me now?
I can hear you now.
I can hear you too.
Okay. Okay. Integration tests. All right, so let's say we're going to do an integration test for Scramble. Scrambles the thing. All right. So, and we're going to say that we're going to expect that Scramble is going to take a string A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. How many characters there? We're going to scramble that string. And so we're going to expect that it is going to, let's lowercase that. So it's going to trim it, reverse it, and then uppercase it, right? So 2 equals trim, reverse, uppercase. So trimming it would give us the first 10 characters. So that would be these guys, right? So it's going to trim it, and then it's going to reverse it. So ABCD becomes JIHGFEDCBA, right? So trim, reverse, and then uppercase, like that. So this is our integration test, right? So return string. It's going to fail at first because we're not doing anything. At least it should fail for the right reasons, right? Okay. So to put it all together, right? What did we say? Trim, reverse, uppercase. Trim, string, reverse, reverse that, and then uppercase that. Uppercases is not defined, so it's not. Uppercase is not defined. Well, that's more surprising. Upcase. That's what we called it. Okay, so so you can see conceptually here, right? Like these could be called unit tests, right? Because they're testing smaller units of our application. If our application is this scrambler, the integration test is testing this scramble method, but on its way to testing the scramble method, it's also kind of testing reverse, trim, and upcase at the same time, right? So you could make the argument that, well, we don't even need these tests, right? Because if any of those functions, if I break any of these functions, right? So let's take substring, for instance, right? If I break this by saying, oh, I'm gonna change this number to 12. If I run these tests now, if I just run the integration test, it's gonna catch it, right? This test failed. The reason I went unit tests, one of the reasons I went unit tests, is that it's not at all obvious to me why the scramble test failed, right? And it becomes less and less obvious the more pieces the scramble function has in it that it's doing, right? Like here I can see that there's something about the length that's off. So I'd probably go and look at trim, right? But this is a really simple application. As the application gets more complicated, looking at one failing integration test and knowing exactly the piece in your code that's broken is really hard. When I have all these things in place, I have these unit tests in place. Now, when my tests fail, my integration test is going to fail, but also the trim string, this trim unit test is going to fail. So I know exactly, oh, I've got something wrong with the trim function. And that gets a lot easier to like, then I know exactly where the bug is, exactly where to go fix the bug. So unit tests are useful for that purpose. The integration test is useful because it doesn't matter how great reverse and upcase and string are. If I upcase before I reverse, all my unit tests are going to pass, except trim, because apparently I didn't fix that yet. Trim, all my unit tests are going to pass, I said, there we go. And so will the integration tests, because reversing and upcasing are interchangeable. That's right. Ha. Let's try that with something else. So if I move trim out here, right? So if I trim last after reversing, that's a good way to break it. There it is. So my unit tests are all passing, but my integration test is failing, because the thing that's broken is exactly the logic about how these different units are stitched together. If I stitch them together wrong, my unit tests will never fail. All my pieces are working great. They're just not stitched together in the right way. And that's why you need integration tests. And you may have noticed that this distinction between unit tests and integration tests is a little arbitrary, right? They're all just functions. All these tests are just for functions, and they all happen to be for pure functions, right? But in the context of this application, right, there's different levels of abstraction. And so you'll find that it's not always a clear distinction between this is a unit test, this is an integration test. What you end up having is kind of like unit tests, or let's just call them tests that operate at different levels of abstraction, right? Where you have unit tests that are testing like very small units, very like small core things in your application. And then you may have a layer of unit tests on top of that that's testing higher order functions or more abstract functions that are like combining more of the smaller units, right? But then you may have like an even higher level of testing that's testing like end-to-end testing that's just saying, hey, you know, we're going to run this app from the command line and just see what it prints out, and not test any function in particular in isolation. But generally, that's the distinction between a unit test and an integration test. An integration test exists to sort of test the wiring between smaller units, where a unit test is sort of defining a sort of a basic indivisible unit of your application. Hopefully that made some sense. Was that helpful?
Yeah, that was really helpful.
Cool. Can you talk about how to set up Babel? If/when we should. Yeah, so Babel is a deep subject that I probably don't even know as much about it as I should, but the 30,000 feet description of Babel is JavaScript, unlike any other language, is defined by a committee of lots of different organizations that write their own versions of JavaScript. So what does that mean exactly? If you're using a language like Ruby, there's a guy named Mats who lives in Japan and invented Ruby one day. Probably took more than a day. And he decides what the Ruby language is. And he decides what's valid Ruby and what's invalid Ruby and how it's going to work. And he's built the Ruby interpreter that basically takes Ruby code and translates it into something your computer understands, right? All languages work that way. With JavaScript, and so with something like Ruby, right, there's that like reference implementation. This is exactly what Ruby is and how it works and how it should always work. And there are alternate versions of Ruby out there. So there's Ruby that runs on Windows and Ruby that runs on Linux, right? There's two different sort of platform versions of Ruby, but they all work the same way in that Ruby code that you write for one should work the same as Ruby code you write for another, right? With JavaScript, you have this situation where JavaScript was invented in browsers. So you had somebody was writing a browser and decided, hey, I want to have some interactivity on this page. I want to be able to write some code and embed it in this page. And I'm going to use a Java-like syntax and create this language called JavaScript, right? I don't think they even called it JavaScript to begin with. And so over time, different browsers were like, oh, this script in the browser thing is really cool. We're going to implement that too. But none of them implemented it the same way. And it's gotten better over time, but you still have a whole bunch of different browsers out there that all have their own implementation of JavaScript. And there's slight differences between them. And more things are getting consolidated, right? But the issue is, you still have to deal with like all of those different versions of JavaScript that are out there. And now it's not just one browser had a different idea about JavaScript than the other. But as new features come to the language and someone decides, oh, it'd be really cool if JavaScript had this cool new feature. Well, to actually use that in your JavaScript, you have to make sure that every single person that develops a web browser updates their version of JavaScript to support that new feature, right? So we're in a situation now where there are just a lot of different versions of JavaScript out there. And because it runs in browsers that you don't control, the process for like rolling out new official versions of JavaScript is slow and involves getting a whole bunch of people on board and deciding what direction we're going to go in and what features are going to be in and out. So what Babel does is basically say, okay, we'd really like to use these fancy new features that people are putting in the JavaScript language, but none of the browsers support them yet. And Node, for instance, doesn't support them all yet. So what Babel does is it takes your JavaScript that you write and it lets you write JavaScript using like the newest, fanciest version of JavaScript that hasn't really been implemented anywhere yet. And then it takes that and it rewrites it using JavaScript that is valid in older versions of JavaScript. And it's kind of smart enough to target different things and say, oh, I can translate your fancy cutting edge JavaScript into whatever JavaScript IE 12 is going to understand, or IE 8 or whatever. So that's the purpose of Babel at like a really high level. So how does it work? How do you set it up? The quick way to do this, and there are probably a few different ways, but let me walk through an example right here. Babel example. Okay, so if we initialize a new npm module in Babel example, let's get these things in here. The quick and dirty way to get this going is to, we're gonna npm install save dev Babel CLI, Babel register, and Babel preset env. And I'll explain what each of these things are in the course of setting this up, all right? I'm gonna install these three things and we'll use each of them and see how they work. Hopefully this won't take forever. I shouldn't have said hopefully it won't take forever because that's just inviting trouble. Come on, internet. Setting up limiters in the next office hours. Yes, I can. In fact, what I'm going to do is I'll add a section to this office hours document for July. What is it? It's going to be later. I don't know. I'll add a note next time. Where's the little thing with the buttons? There it is. Linters. All right, there we go. So this stuff is installed. So So a really common way to set up an application when you're using Babel and you're going to be like writing one version of JavaScript and then compiling it into another version is to put your code in a source directory. So I'm going to make that source directory and I'm going to create an index.js file. And I will just import hello from util. So I'm going to use this sort of ES6 import syntax instead of having to do require, right? And import a function from something called util and then call it. Say hello, Trevor. And then down here also in my source directory, I'll create that util.js. And I'll use this export function, hello, name. Okay, so that theoretically should work. All right, so I've got some JavaScript here that is like ES6 JavaScript. Okay, so now what we're going to do is we're going to run a command called, is it babel? Yeah, babel. And we're going to point Babel. So this is what Babel CLI gives us. Babel CLI gives us this Babel utility. And we're going to point it at our source directory, and then we're going to say -d lib, which means take the source directory, rewrite all the code that's in there in a different version of JavaScript, and then put the output in a lib directory. Haven't created the lib directory, but that's okay. Babel will create it for us if it doesn't exist. Command not found, Babel. Don't tell me that. Oh, that's right. So I installed it in this application. So it's actually down here in my node modules directory. Babel. There it is. So source-d lib. So you can see it's telling me, okay, I took the index and the util file from source and I wrote new ones in lib. And if we look at those files, lib, index, so this code looks exactly like the code in my source index file. Let's look at them side by side. These two things are identical. And the reason they're identical is because we haven't, well, they're almost identical, right? We've gotten some extra space in here. But the reason they're identical is that we haven't told Babel what version of JavaScript we want to target. Right? So it knows we're writing like ES6 JavaScript or whatever, but it doesn't know like, well, what do you want me to translate that into? And the way that you do that, there's a couple ways. You can create a separate file in your project that defines what features you want to turn on and what platform you're targeting. But the simple way to do this to get going is if you've already got a package.json file, you can just add that information in here. So we can create a new element in package.json called Babel, new attribute, and then we're going to set presets. Did I do that right? Yeah. Presets, and you give it an array of presets, and this is where we're going to specify env. So one of the three things we installed was Babel preset env, which gives us this preset option. And env is sort of a convenience thing where it'll look at the environment that we're in. So right now we're running a certain version of Node, and it'll check and see, and it'll see that we're running version, what version are we running? We're running Node version 6.11.1. So it will compile our code down to a version of JavaScript that Node version 6.11.1 understands. And something about that package JSON file looks off to me. Let's see. No, I think we're right. I can get my computer to stop freezing up. Okay, I think that's right. So now if you run this babel command again, we should see the code in lib index looks different. Whole lot of different, right? So now let's look at these two things side by side, source, index. So here's my code, and here's my code compiled to work in Node version 6. And it's not meant to look pretty. It's not meant to be read by humans. So it's a lot of like weird stuff going on. But you can kind of see that they've taken my require here and they've changed it. They've taken my import, that is, and changed it into a require. So now, if I just use Node, if I try and run Node on my source file, I get an error because Node does not understand the version of JavaScript that I'm writing. But if I run Node on the file that was created in the index for me, that was created in lib, Node can run that just fine. So, so in this method, right, like you'd write your code, you'd run this babel command to sort of compile your code into the right version, and then you'd like release your module or deploy your code or whatever. And to make that a little easier, you'd probably come into package.json and create a build script. So we've got testing, let's add a one for building. And here we would say babel source-d lib. So that's just that command we ran. And because we're doing this inside the package.json, we don't have to give the path to babel down in our node modules. NPM will do that for us. So we can just say babel and it'll, by default, it'll go find the one that's installed in node modules. So that makes this a little bit easier. I can say npm run build to run my build. But that's still annoying in development, right? I don't want to have to do that every time I want to just, you know, node. I want to be able to do this, right? I want to be able to just like run my code and not have to worry about compiling it every time in development, right? It's an extra step that I don't need. And that's where that third thing that we downloaded comes in. Remember, we downloaded, we installed Babel CLI, Babel register, Babel preset end. And we saw Babel CLI, that's what gives us that Babel command we use to build. Babel preset end is what allows us to say presets end in our package.json to tell it like what to compile to. Babel register is the last thing we're going to use. And Babel register is a module that will sort of like reinterpret your JavaScript code on the fly. It basically hooks into the require method. And once Babel register has been required, any files that are required after that get sort of parsed through Babel and rewritten sort of on the fly. So there's a couple different ways to do this. If you've got tests, so let's say that we've got tests. Well, let's hold off on that for right now. So often what you'll see is a bin directory in the application, right? And in the bin directory, we could have a dev script. And in the dev script, we could just say require Babel register. And then we'll require our index file, right? Let's check my calendar real quick. Make sure that I'm not going to be late for a meeting. I'm not. Okay. So I'll run a little bit long. Okay, so we're creating this this script here in bin dev that basically like sucks in our index file, but pulls in Babel register first, so that, sorry, this should be source index, so that we can actually require in our source index file, and it'll just get like kind of rewritten on the fly. And then of course you could have a similar file for production that just pulls in the compiled version, right? So then with these two scripts, you can go into package.json and we can change, we could have a start. So this, if you had like a web server, this is kind of what it would look like, right? You'd have a start script where you just be node bin dev and a start prod script that runs the one for prod. So we just kind of created two entry points into our application. One of them just is basically the same as doing node index, right? Node lib index, and just runs the compiled version. But this dev version, before it loads our source version of the index, it adds in Babel register. So now we can see that, right, if we just try and do node source index, we still get that error. But if we say npm start, we get a different error because I can't type to save my life. We need commas at the end of our things. There we go. So that works, right? And you can see it's running, you know, node bin dev. And in production, we would just do start prod, pm run start prod, and it runs the prod example. So that's like a quick and dirty way to get Babel set up. There's a lot of different configuration you can do with Babel. There's a lot of specificity you can get into on like which features you want to turn on, which architectures you want to target when you're compiling. You know, are you compiling your code to run in like certain versions of certain browsers or different versions of Node? But that presets env thing is a nice way in development. If you just want to play with ES6, it's what I found to be the quickest and easiest way to get going.
Trevor, do you mind just going over what Babel register is again? Just not its usage, just what it actually does.
Yeah, so Babel register basically hooks into the require statement. So let's look at this bin dev. What I'm doing here is I'm saying, okay, first require Babel register. A node will go and it'll read in Babel register. And what Babel register is doing is it's basically redefining the require statement. It's redefining this require function. And what it's saying is, okay, when you ask me to require a file, I'm actually going to go and read all the text out of that file, and then I'm going to compile it in memory into a version of JavaScript that we're targeting. So in this case, it's going to rewrite it into that version of JavaScript that Node 6 understands. And then it's going to pass it to the real require method to sort of move on its way and go about the normal process of reading your code. Does that make sense? So it's sort of like a just-in-time translation, where when we run Babel on the command line, we actually like translate all those files, write them out to new files, and then we can point Node at those new files. Babel register is just rewriting require to do all that work just in time. It basically rewrites the file right when the file gets required. So right when you're just sucking in the code to be used in your application, it sort of does it on the fly, so that you don't have to do that like compile step before you run your app every time you change something. Does that make sense?
It kind of does. I guess what still remains unclear is if you how can I, like when you run start production, right? And you're pointing it at the, like when did you create that, and did you have to build that? Did you have to, I guess I'm confused as to when the build happens, like why you wouldn't have to do this for the production.
why you wouldn't have to do Babel register for production?
Yeah.
Right. Oh, that's a great
What's
question.
the
Okay,
difference between those two files?
right. Yeah. So let's look at everything together. Bin prod. Okay. So the difference here is for production, I'm pointing at the lib file, right? So this is the file that has already been compiled.
But do you always have to manually run build? Like, do you always have to manually
Yes.
run that script? And when would you
Yes, you do.
manually run that? Before you ran the production?
Right. So yes, you'd run it before you ran production. So if I didn't have Babel register, if I didn't have it at all, then what I could do is I could come in here and let's look at source index. I'm in here and I'm writing code. And say I want to change this to Amy, right? So say that I don't have Babel register at all. So my only option here is to node lib index, right? These lib files are the only thing that the nodes can understand, right? So if I run that, it still says Trevor because I've only changed the source file. I've only changed the ES6 version. So I've got to remember to say, okay, well, first I have to npm run build so that it updates the lib version of the file. And then I can run that and I should see my changes, right? Hello there, Amy. Right? So that would be the normal like development pattern, like make a change, rebuild, rerun. What Babel register, it takes out that step and it's slow. The reason I wouldn't use Babel register in production is because it's really slow. Because every time it reads a file, it's doing that compilation, which takes a little while.
So could you include the build step in the script that you ran for the start production?
I totally could, yeah. And that would not be a bad idea, right? You could say start, so I could do this and I could just be npm build and npm run build and then node bin prod, right?
Okay.
This is another way to not use Babel register. I could do the same thing for dev and prod. It's just for this start script, I can just always build before I start the thing. Okay. So I make sure it's always
would that be the same, like, would that be the same weight? Like, I know that you spoke about it being like, every time you were running Babel register, it like took a lot. That's why you wouldn't do it in production. Is it basically the same thing as running the build at the beginning?
Yeah, my intuition is that running the build at the beginning is going to be slower than Babel register altogether. Okay. Because you're starting a whole nother node process and running the build and then shutting it down. And then you're starting a new node process to like start the thing again. And npm run build is going to compile all of your files. Whereas Babel register just compiles them as they're used.
Okay.
So it's possible there are parts of your application that aren't even going to get touched in a particular run, right?
Right.
And so there's no point recompiling those every time.
But would it make sense to shift that? Would it make sense to shift that npm run build into the start production script?
It would, yeah.
So it just did it that one time when you ran for production?
Yeah, and it depends, and depends on your deployment strategy and that sort of thing. Some people would say that it's good to have the code that's going to be running in prod. You want checked into version control, right? So you might put this npm run build in a pre-commit hook or something like that, so that every time you're about to commit code, it makes sure that everything is built before you commit, so that like your lib and source directories are always in sync in all of your commits. That might be one way to do it. And so then when you get to prod, like it's already built. It can't get here if it hasn't been built. But yeah, you would definitely probably want to automate this build step somewhere so that it happens before deploy, or it happens in the start command or something like that, or it happens before code gets checked in. Yeah.
Well, thanks. I really appreciate that.
Okay. Is that a little more clear?
Yeah,
I feel like Babel would be a good thing to do a lecture on at some point, which would require me learning a little bit more about it.
Yeah. That was a good
hopefully
way to set up, because I noticed that you were using it in the yesterday when you did the testing lecture. You had used it in your, like I noticed it in your package.json, and that you were also using import. So I was just like, how
Right.
do you just set it up for a simple kind of app like that?
Yeah, yeah. I ended up turning it on primarily because I like that import syntax so much better than doing requires. It just makes me
Totally.
happy.
Okay.
And the destructuring that you get in ESX is also like, it's just so, it's so nice that it's worth it for me to like do these couple of steps when I'm doing a new project. But,
Cool, thanks. I really
Ellen,
appreciate
I'm
it.
going to add use strict to the office hours thing for next week. Since we're over time here, I'm going to shut this down. But also, if you want to we continue to ask questions in the Phase channel, and we can keep talking about stuff. But for now, I'm going to stop the recording. Thank you all for coming with such good questions. This was fun, and I'll see you around.